The Iwate Ichinohe Tunnel is a massive 25.81-kilometer railway tunnel cutting through volcanic mountains. It was built to connect regions, overcoming the impossible challenges of the rugged Japanese terrain.
In the late 1990s, Japan embarked on this ambitious project to build the world's longest land railway tunnel.
Deep underground, the mountain fought back, bending steel supports and threatening the integrity of the tunnel structure.
Engineers faced extreme geological pressure, requiring constant monitoring and innovative solutions to keep the project moving forward. They used advanced 3D geological modeling to map the mountain's interior and plan the safest route for the tunnel. The goal was to create a direct path, cutting travel time significantly for passengers across northern Japan.
Geological surveys were crucial, revealing layers of volcanic rock and fractured ground that could compromise the tunnel.
Sensors provided real-time data, warning of critical deformations that required immediate intervention to prevent structural failure.
The pressure was immense, as the mountain constantly shifted, testing the limits of the concrete and steel reinforcements.
Steel supports were bent like paper, a clear sign of the extreme geological forces at play deep underground. The tunnel was not just a construction project. It was a battle against the raw power of nature itself.
Controlled blasts were used to clear the path, but each explosion brought new risks and challenges to the engineering team.
The TBM was a marvel of engineering, capable of grinding through solid rock to create the tunnel's path.
Shotcrete was applied to stabilize the walls, providing a crucial first layer of protection against the mountain's pressure. Precision was key, as every component had to be perfectly aligned to ensure the safety of the high-speed trains. This is the story of how Japan built the Iwate Ichinohe Tunnel, a testament to human ingenuity and perseverance.
The tunnel has become a vital link, connecting cities and transforming the way people travel across the country.
Inside the train, passengers enjoy a smooth and comfortable journey, unaware of the engineering marvel beneath them. Each step of the construction was a calculated risk, requiring constant adaptation to the changing conditions of the mountain. The new route was designed to be faster and more efficient, cutting through the mountain rather than winding around it. Surveying the terrain was the first step, using drones and advanced equipment to map the mountain's surface and interior. Core samples provided a glimpse into the mountain's composition, helping engineers understand the challenges they would face during excavation. The path was carefully chosen to minimize environmental impact while maximizing the efficiency of the railway line.
The expansion was a major investment, promising to reduce travel time and improve connectivity across the region. Building around the mountain would have been too slow and costly, making the tunnel the only viable option.
The project was a feat of engineering, requiring precision and innovation at every stage of the construction process. The mountain was full of surprises, with complex geological structures that made excavation a constant challenge. Engineers had to make difficult decisions, balancing safety, cost, and the timeline of the project. They chose to drive the tunnel straight through the mountain, a decision that would define the success of the project.
The path was mapped with extreme precision, ensuring that the tunnel would be safe and efficient for years to come.
Work continued around the clock, with teams working in shifts to meet the demanding schedule of the project.
The tunnel was a beacon of progress, a symbol of Japan's commitment to infrastructure and connectivity. It would become the longest land railway tunnel ever built, a record that stood for many years. But length was never the greatest challenge. The real battle was against the mountain itself. The real battle was hidden inside the mountain, where unstable rock and groundwater posed constant threats to the tunnel.
Before excavation could begin, Engineers needed to understand what lay beneath the surface.
Hundreds of geological surveys were conducted, revealing the complex layers of the mountain.
These surveys were essential for planning the tunnel's path and ensuring the safety of the construction teams. The drilling process was intense, with water and rock debris being constantly removed from the site.
Each core sample was carefully analyzed, providing valuable data about the mountain's composition.
This data was used to create detailed 3D models, guiding the engineers in their work. The team worked together to overcome the challenges, using their expertise to ensure the success of the project. The mountain was full of surprises, with complex geological structures that made excavation a constant challenge. This section was highly unstable, posing a significant risk to the tunnel's structure. The pressure was so great that the tunnel walls were in danger of collapsing. The question was no longer where to dig, but how to build a tunnel that could withstand the mountain's pressure. How do you build a rigid concrete tunnel inside a mountain that never stops moving? If the answer was wrong, the surrounding ground could slowly squeeze the tunnel until its structure failed. Groundwater was another major challenge, seeping into the tunnel and weakening the rock. The mountain began expanding instead of remaining stable, a sign of the immense pressure inside.
Before the first blast was fired, the engineers already knew they were facing a problem no blueprint alone could solve. The only way forward was to enter the mountain and learn from it 1 meter at a time.
The construction was a massive undertaking, with 7 different construction sections working simultaneously. Japan divided the project into 7 construction sections to speed up the process. Access tunnels were driven deep into the mountain, allowing multiple excavation crews to work at the same time. These access tunnels were crucial for the project's success, enabling efficient work across the entire site. Every team advanced independently through different geological conditions, adapting their methods as they went. The team worked together to overcome the challenges, using their expertise to ensure the success of the project. Even a deviation of a few centimeters could prevent 2 excavation headings from ever meeting. Progress was tracked constantly, as all 7 excavation fronts moved closer together. The team's dedication and precision were the key to the project's success. The question was no longer where to dig, but how to build a tunnel that could withstand the mountain's pressure.
Progress was tracked constantly, as all 7 excavation fronts moved closer together.
Thicker shotcrete created a stronger first layer of protection, ensuring the tunnel's stability. Longer rock bolts anchored the unstable ground, providing additional support to the tunnel walls.
Additional steel ribs were installed where ground pressure was greatest, reinforcing the tunnel structure. Sensors measured movement around the clock, ensuring that any deformation was detected early. If deformation exceeded the safety limit, excavation stopped immediately, allowing for adjustments to be made.
Every meter of progress depended on real-time engineering decisions, ensuring the safety of the project.
The mountain tested every solution, but slowly, the tunnel began winning the battle.
Years of excavation brought all 7 construction sections closer together, a testament to the team's hard work. The remaining rock became thinner day by day as the 2 excavation headings finally met.
Surveyors continuously checked every tunnel heading, using high-precision instruments to ensure perfect alignment.
Each breakthrough had to match the original alignment within just a few centimeters. Day by day, the remaining rock became thinner until the final breakthrough was achieved. Then came the final controlled blast, a moment of triumph for the entire engineering team. The last wall of rock disappeared, and the 7 separate tunnels became one continuous railway tunnel. The greatest obstacle had finally been conquered, a moment of pride for everyone involved. Now the empty tunnel had to become a Shinkansen railway, a new challenge for the team. Breaking through the mountain was only half the project. The railway installation was just beginning. Engineers began installing the railway inside the tunnel, a complex task that required precision and care. The long tunnel was a massive undertaking, but the team was ready for the challenge. Concrete slab tracks replaced temporary construction roads, providing a smooth and stable surface for the trains.
New Shinkansen tracks were aligned with millimeter precision, ensuring the safety and efficiency of the railway line.